Winter is coming, and well, there's nothing worse than watching the temperature drop while your electricity bill skyrockets. For history enthusiasts and DIY fans alike, there's a way to stay warm while embracing the ingenuity of past generations, building your own oil lamp convection heater. On this channel, we dive into tools, techniques and designs that pay homage to practical historical solutions. And honestly, today's project is no exception. Before we dive in, don't forget to like this video, share it with your fellow history lovers, comment with your own experiments or questions, and subscribe to The Hard Past so you never miss a step in reviving the cleverness of the past. The heater we're about to explore isn't just a quirky gadget. It's a functional, cost-effective and historically inspired solution capable of warming a two-bedroom cabin for less than $5 a week. Its design allows it to operate on multiple types of oils, many of which can be sourced cheaply at wholesale prices. Beyond that, it reaches a temperature of up to 500 degrees Fahrenheit, providing a steady, reliable heat source that's reminiscent of early 20th century cabin stoves while avoiding modern electricity costs. Let's begin with the foundation. The core of this heater is built from steel gutters and a metal ammo box, reflecting the kind of resourcefulness that people relied on before mass-produced heating systems. Using a hand grinder, holes are precisely cut into the gutters and ammo box to allow proper airflow and access points for the oil wicks. This step may sound straightforward, but patience and accuracy are critical. Historical heating devices failed often because small miscalculations led to inefficient burning or dangerous smoke buildup. Removing the original rubber seal from the ammo box and replacing it with a high-temperature gasket is an essential upgrade, ensuring safety and longevity. One of the most visually striking elements of the heater is the window added to the door. This requires cutting a section of the metal and installing heat-resistant oven glass, secured with a dual gasket system for a perfect seal. The effect isn't just functional. It evokes the warm glow of old-world fireplaces, offering both heat and ambient light, much like the oil lamps of colonial homes or frontier cabins. Installing a concrete board behind the heater, painted black, further enhances heat retention and, mirrors historical techniques where backplates and stone or brick surfaces radiated warmth into living spaces. For oil storage, a metal container serves as both the fuel reservoir and a visual gauge. By installing a small window, it's easy to monitor the oil level, ensuring consistent performance without guesswork. The heater uses multiple braided oil lamp wicks, whose length and thickness can be adjusted to control the intensity of the flame. This mirrors the careful attention early settlers gave to lamp maintenance, balancing fuel efficiency and brightness. If the wicks are too long, the flame produces smoke and unburned fuel, a problem that was, pretty well understood by anyone who lived with oil-based lighting. A modern touch that complements historical ingenuity is the use of a three-dimensional printed fan mount to support a standard computer fan. Operating at 12 volts direct current and 1.6 amps, this fan efficiently circulates heated air throughout the cabin. It can run on a small battery, making it independent of the electrical grid, a perfect nod to off-grid survival solutions used in the past. The fan not only accelerates heat distribution, but also keeps the heater cooler and safer to operate, much like the carefully designed vents in early cast-iron stoves. When measuring the heater's performance, the temperature readings are impressive. The input air enters at around 77 degrees Fahrenheit and is heated to approximately 134 degrees at the exhaust pipe, with the top surface reaching temperatures capable of cooking food. Despite these extreme temperatures, proper ventilation and spacing prevent harmful fumes from entering the living space. A dedicated oxygen intake pipe and a 1-inch gap between the concrete board and the heater ensure continuous airflow and safe operation, reflecting centuries-old principles of combustion safety. Running the heater continuously for a week demonstrated its efficiency. A half-gallon oil reservoir lasts roughly 7 days when the heater operates 12 hours per day. This economy in fuel mirrors the frugal practices of earlier generations, for whom maximizing every drop of oil was a necessity rather than a choice. Beyond warmth, the heater provides light, giving a cozy glow reminiscent of gas or kerosene lamps from the early 1900s. This heater isn't just a functional object. It's a bridge between the ingenuity of the past and practical solutions for today. Its ability to operate on cheap oils, produce significant heat, and function independently of electricity makes it a perfect project for anyone interested in history, survival, or sustainable living. Every weld, gasket, and carefully adjusted wick tells a story of resourcefulness that has kept people warm for centuries. If this guide has inspired you to take your own historical heating project into your hands, now is the perfect time to start. Build carefully, observe the results, and, don't hesitate to tweak your design based on the oils available or the size of your space. The more you experiment, the more you'll understand the principles that guided early engineers and settlers in crafting practical solutions from limited resources. Remember, if you enjoyed this detailed walkthrough, hit the like button, share the video with friends who appreciate history, and DIY ingenuity, comment with your own experiences or questions, and subscribe to The Hard Past to stay connected with projects that celebrate the brilliance of the past. Every new subscriber supports the continuation of these hands-on explorations, helping us uncover and revive techniques that are both fascinating and functional.